Hello students, in this video I am going to discuss the distance and displacement. Generally the distance will be denoted with S and it is measured in terms of centimeter in CGS system, meter in SI system. And it can be measured in terms of kilometers, angstroms, nanometer based on the situation. Generally, the distance is measured in terms of centimeter in CGA system and meter in SI system. Same way, the displacement can be written as denoted with S bar. What is this bar? In the next second point we will discuss. And it is also measured in terms of centimeter in CGS system and meter in SI system. While coming to the definition of distance, the length of the path covered by a body, the length of the path covered by a body is called distance, and the shortest distance between initial and final position is called displacement. For example, here, so this is your home and this is your school. You have the road like this and you have traveled finally to the school like this. So there is no path in a straight line to travel from your home to school. You need to travel like this. Now, so what is the distance traveled? If you measure the length of the path traveled by the student here is called distance. And this distance is nothing but the length of the actual path. Suppose we are measuring the length of this one and it may not have any specific direction, but it has some magnitude. That may be 1 kilometer or 2 kilometers or something. But the shortest path, so home is nothing but initial position and your school is suppose a final position. The shortest path between initial position and final position is possible only if we are drawing a straight line between them. This is the shortest path. This shortest path, shortest distance between final position and initial position is called displacement. This displacement has some magnitude, that means it may have 1 kilometer or some value, and it has some specific direction. That's why the displacement is denoted with S bar. It is a vector quantity. Come to here. Scalar and vector. What is meant by scalar and what is meant by vector? Any physical quantity. The physical quantity is nothing but the quantity which can be measurable. For example, if you are using distance or displacement or speed, velocity, like that. All the terms maximum whatever we are using in our physics. So some of the quantities may require only the magnitude to represent it. Some of the quantities requires both magnitude and direction. If the quantities which requires only magnitude, if that requires only magnitude, it does not require any direction, then the quantity is said to be scalar quantity. For example, so the mass of a body is, suppose say 1 kilogram. So this 1 is the magnitude, and here there is no importance of the direction. For example, we are measuring the same 1 kilogram of a body in any direction, its mass will remain same. It does not depend upon any direction. So to check any given quantity is scalar or vector, you can question yourself, what is the magnitude? If you get the satisfied answer, definitely will get the satisfied answer. One more question, what is its direction? If you get satisfactory answer, that may be vector quantity. If you don't have any satisfactory answer, compulsory there is a scalar quantity. While coming to vector, so this vector requires both magnitude and direction. It has to obey exactly, if you want to say means, and it should obey the law of vector addition. What is meant by law of vector addition? In the next coming videos, we will discuss. Here, for example, this is a block of mass M. A force F is acting, that F is supposed to say 5 Newton. Now, what is the magnitude of the force? The magnitude of the force here is 5. What is its direction? It is acting on the body towards right. That means it has some direction. If you take such type of quantities, they are called as vectors. Example for vectors, you can write displacement, just now whatever we are discussing, velocity, acceleration, force, momentum, etc. So while coming to point 3, the distance is always positive, and if the body is not moving, then the distance may be 0. If the body is not moving, we no need to discuss about distance or displacement. So generally, it has a positive value. While coming to displacement, suppose it is x-axis, it is suppose origin, it is 1 meter, 2 meter, 3 meter, like this. A body is initially, or a person is standing at O, is moving towards right. The initial position is O, and he has travelled up to point A, suppose say 3 meter. Now in this case, what is the value of displacement? The value of displacement here is 3 meter towards right, 2 meters towards right. Okay. Suppose if the body is, the person is moving from O to A and again coming back to O. That means initial position, final position, both are same. Here displacement is 3 meter towards right. Here the displacement will becomes 0. The magnitude of the displacement becomes 0. Why? Means the initial position, final position, both are same. Okay. Suppose if the body started from point O to A and again is moving from A to some other point. It is suppose say -1 meter, it is -2 meter. Then finally the displacement is -2 meter. The displacement here is -2 meter towards left. Minus represent the towards left. That means here direction also is there. That's why the displacement may be either positive or negative or 0. And if you observe here, the distance depends upon the path followed. Why means we are measuring the length of the path traveled by the body. So it depends upon the path. While coming to displacement, it is independent of the path. Why it is independent of the path? It depends upon the only initial and final position. Initial and final position. Initial and final position. And it is always greater than or equal to displacement. So the magnitude of the distance is greater than or equal to the magnitude of the displacement. Here also the magnitude is always less than or equal to distance. The magnitude of the displacement is smaller than or equal to distance. How? Suppose say the same example, above example only we will take it. This is point O, it is point A, it is 1 meter, 2 meter, suppose say 3 meter. Initially the body is travelled from O to A. In this case both the distance and displacement is travelling a straight line path. Whenever is travelling straight line path, according to the definition of distance, the distance travelled is the length of the actual path. Its value is 3 meter. And what about displacement? Displacement is also 3 meter towards right. In this case, both distance and displacement both are same. Okay. Suppose he is coming back to point O. Is coming back to point O. In this case, the magnitude of the displacement is 0, but the distance travelled is equal to 3 meter plus 3 meter, that is nothing but 6 meter. In this case, the distance travelled is more than the magnitude of the displacement. So these are the few points based on distance and displacement. This video is done based on the request of the students who are in secondary to clear the concepts from basics, at least foundation level. Thank you.